All right, we are on to exercise number 8 of surface area and volume of pyramids. So we have a regular right pentagonal pyramid. So the base is a pentagon, and the apothem is 12. We need to determine the volume of the pyramid, and it tells us that the angle formed by the slant height of the pyramid and the apothem is 50 degrees. So we need to know our vocab for this problem as well. We're going to round it to the nearest tenth. So nice little clue, like could be some trigonometry involved, some right triangle trigonometry, something along those lines if we're going to round to the nearest tenth. So we know that the volume of a pyramid is equal to 1/3 the area of the base of the pyramid multiplied by the height of the pyramid. When we talk about height of a pyramid, we're talking about the altitude, so like from the vertex to the center of the base. So we need to get the area of the base, and the base is a regular pentagon. So let's start there. Let's get the area of that base first. So let's draw in a regular pentagon, something along the lines of that. Each side is congruent, and the apothem is 12 units long. So remember that the apothem goes from the center of the pentagon, is perpendicular to the side, and it's going to cut the side in half. So if we call this piece x, then this piece is x. So then we're calling the entire side of the pentagon 2x units long. The apothem is 12. Okay, well, hopefully based on the last unit and kind of the connections that you've made with prisms and such, we need to determine the angle measure of a regular pentagon. You've done this so many times, you might even know it off the top of your head, but if not, we have a quick calculation. We could kind of do one of two things. We could do 180 times the number of sides that we have, so 5 minus 2 divided by 5. Or since the sum of the exterior angles is always 360 and an interior angle is always supplementary to an exterior angle, you could do 360. I'm sorry, that's not true. We could, since an interior angle is always supplementary to an exterior angle, and the measure of the sum of the exterior angles always adds to 360, we could do 180 minus 360 divided by 5. Now either of these calculations should give us the same thing. So if we do 180 times 3, and then we divide that by 5, we get 108. If we do 180 minus 360 divided by 5, we get 108. So each interior angle of the regular pentagon is 108 degrees. By this point of the year, we might have that stored upstairs, just because of how often we've seen regular pentagons. So each angle is 108 degrees. Well, with the apothem, we're kind of looking for right triangles. So if I draw in and complete this triangle on either side, well, we should know that all of these triangles would be congruent. So that 108 is split into half. So this angle should be 54 degrees. Well, that's helpful because now I can get the side length, and if we remember the area formula for a regular polygon, it's 1/2 the perimeter times the apothem. So if I can solve for x, I'm going to be able to solve for the perimeter, and I already have the apothem, so I'm going to know the area of the pentagon. So let's show this work over here. We need to figure out what x is. So if you look, x would be adjacent to the 54 degree angle. 12 is opposite, so we'd take the tangent of 54 is equal to the opposite side of 12 over the adjacent side of x. When we solve that, we're going to get x is equal to 12 divided by the tangent of 54. If we put that into the calculator, we get x to be about 8.718-ish. So x is, and we'll keep that number in the calculator, but I'll write it out as x is approximately 8.718. We'll store that in the calculator. We'll keep all the digits in the calculator, but our goal is to get the perimeter. So let's see what 2x is. So 2x would be approximately, well, let's double that, about 17.437. Well, 2x is one side of the pentagon. So if we want the perimeter, we're going to multiply 17.437-ish by 5. So the perimeter is going to be approximately equal to 17.437. Multiply that by 5. So when we multiply this by 5, we get the perimeter to be about 87.185. So 87.185-ish. Okay, so then we should be able to get the area of the base. So kind of number 3 in our work here, the area of the base would be equal to 1/2 the perimeter times the apothem, so about 1/2 of 87.185-ish multiplied by the apothem of 12. So if we multiply this by 12 and then divide that by 2, we get the area of the base to be about 523.11. Okay, so we'll hold on to that because it's part of our formula. So now we just need to get the height of the pyramid. So if I go back to my picture over here, at the beginning we said, just remember that the height of the pyramid means from the vertex to the center of the base. So we're searching for the height from the vertex down to the center of the base. So we're looking for the altitude. Okay, well, they gave us a huge clue. There's an angle formed by the slant height of this and the apothem, and it's 50 degrees. So if we draw that in, the slant height, remember, is the height of one of the lateral faces. So definitions are really important in surface area and volume. So the slant height is the height of one of these triangular faces. So there's the slant height. Well, that slant height, remember, this triangle, this lateral face is isosceles triangle. So the height of the isosceles triangle goes to the midpoint. Well, you know what else goes to the midpoint of that edge? The apothem. So the apothem and that slant height form a 50-degree angle. And we know that the apothem is 12 because they told us in the problem that the apothem is 12. So that doesn't change. So that means, if I kind of make my fourth point here, we have a triangle that's formed by the altitude or the height of the pyramid and the apothem, which is 12. That's the apothem. So the apothem and the height form a right angle, and the triangle is completed by the hypotenuse, which would be the slant height. Oh, well, the slant height and the apothem formed a 50-degree angle. That's based on the information given from the problem. So now I can solve for the height of the pyramid. So if I look, I have a 50-degree angle. I want to know the opposite side, and I have the adjacent side. So the tangent of 50 is equal to the opposite side, which is the height of the pyramid, over the adjacent side, which is 12. So that means the height is approximately, put this into the calculator, tangent of 50, multiply it by 12, and we get the height to be about 14.301. Okay, well, since we know the area of the base and we know the height and we know the formula, then we're done with this problem. We just have to put it into the calculator. The volume is going to equal 1/3 the area of the base, which was about 523.11-ish, multiplied by the height, which was about 14.301-ish. I'm going to keep those numbers. I've already kept those numbers in my calculator, so I could be a little more precise when I have to round at the end. So I could do 1/3, and then I could multiply that by the 523.11, so I'll bring that down, and then I'll multiply that by the height, which was about 14.301, and I get the volume to be about 2,493.675. It says round to the nearest tenth, so we're going to round that to the volume is approximately equal to 2,493.675 7 units cubed.